Welcome! In this series of videos, we will look at software add-ons for the PowerBasic, Windows and console compilers. Today we will look at the SQLite library to run SQL queries from your applications. We have, in previous videos, covered Microsoft SQL Server and using PowerBasic to access its databases. However, today we're going to look at another SQL implementation. This is SQLite. SQLite is a C language library that implements a SQL database engine. From this website, we can go to the download page. And from the downloads page, we can pick the particular implementation of SQLite that will suit our purposes. As we're going to be working in the Windows operating system, we will go to the Windows section. And we're specifically interested in the 32-bit version, as we're going to be using PowerBasic, which is also a 32-bit application. So this is a zip file we're going to download. If we have a look inside that zip file, we'll see there are in fact two files in here, SQLite3.dll and a definition file. If we open up the definition file, we'll see this gives us a list of all the exported functions and subroutines within this DLL. Now, there are a large number of these listed, but we're not going to be using all of these today. We'll be using just a minimal amount to connect to a database, to close a database, and to run queries on that database. SQLite is widely used. If we have a look on my computer, we'll see there are a large number of files which have SQLite 3 in the name, and they're all DLLs. There is even one in the Windows System32 folder called WinSQLite3.dll. However, we're going to put the DLL we've just downloaded into the folder which our application sits, just to make sure we have the right version in the right folder and we don't interfere with anything else on the computer. So here is our code folder with SQLite.dll sitting in the folder. This is the most recent version of SQLite for our particular environment. And we've created a little starter.bas file for PowerBasic. We're going to be using the console version of PowerBasic today exclusively. Both the console and the Windows versions of PowerBasic can access SQLite, but just for convenience today, we'll start this very first episode using the console application. And here is our starter application. In order to access these DLLs, we'll need to declare a number of functions. These are the functions that are used within the DLL itself. So the first one we need to declare is the one that allows us to open a database. So we'll put these declarations at the very top of the application before our pbMain function. If you haven't declared functions within an external DLL before, it's quite straightforward. We have the words declare function. This is followed by the name of the function that we're going to be using within our application. Next is the name of the library, in this case SQLite3.dll. The alias name is the name of the function or subroutine within the library itself. This name is case dependent, so if the name of the function had uppercase letters, then we would have to put that in our alias. This allows you to have a different name internally for your function from the name that it is declared within the DLL. For simplicity today, we'll keep both of these names the same. Following this, we have two variables. This particular function takes, first of all, the name of the file to create or open, followed by a database handle, which will be populated when you open your file. This database handle can then be used later on to do other operations on the database. We will add more of these function declarations as we go. There are also three constants we're going to be using within the application today to allow us to determine whether the piece of SQL we've just tried to run is successful or not. These are SQLite OK, SQLite Row, and SQLite Done. We'll cover these as we come to them. So let's now go into the pbMain function and create our first piece of code. The first thing we will declare is our database handle. This is what the DLL is going to pass back to us to let us know the handle of the database we have just accessed. Next, we're going to make a call to this SQLite 3 open function to connect to and open our database. As is common with all of these functions, they will return a value. This tells you whether the function you're attempting to call has been successful or not. So we'll need to declare this return code in our local variables list. So we're passing two parameters to this function. The first is the name of the database we wish to access, and the second variable is the database handle, which will be passed back from the DLL. So just to make our console a little clearer, we'll change the colour on screen. At the moment, as you will see in this code folder, there are no database files. We only have the two files, the PowerBasic code file and the DLL. The way this open function works is if you specify a name of a database file which does not exist, then it will attempt to create that for you. So having called this SQLite 3 open function, it should create a file called test.db. In order to know whether this function has been successful, we can test the RC variable, the return code, to see whether it equals SQLite OK or not. And all we will do is, if it does not equal SQL OK, then we'll print a message out to our console to say unable to open or create the database. If it does return SQLite OK, we will print out database opened. So before we run this code, we will also close down the database, which will be the last thing you do in your application once you've finished using your database. And to do this, we'll need to use another function within our SQLite library. And this function is SQLite 3 close. It takes a single parameter, which is the database handle. So here we will make the call to SQLite close. We will test to see whether we're getting back a value of SQLite OK. If that is not the case, we will say there's a problem closing the database. Otherwise, we will say the database is closed. We will then put a message on the console to say press any key to exit the application. And we will wait for a key being pressed. So a quick compile to make sure it compiles OK, and we will attempt to run our application. And there on screen we have database opened and database closed. Press any key to exit app. So what we should see now in the folder is test.db should have appeared. And there is our test.db file sitting in our code folder. It is 0 in size as we haven't put anything into that database file yet, but it has created the file. So if we run the application once more, it will open the database and then close the database. And the file is still there. So what we've done so far is we have successfully opened a database file using SQLite. We have then closed it immediately. So having opened and closed a file, we'll now want to create something inside the database. If you've used SQL databases before, you'll find that data is held within tables. So our first task is to create a table in the database from our code. So we're going to create a function whose job it will be to create a table in our selected database. So we're going to create a new function called createTable, taking a single parameter, which is the database handle. If this function returns true, we will say the table has been created. If it does not return true, if it returns false, then we will say we have been unable to create the table. So let's now create this new function. So here is the skeleton of our new function taking its single parameter, the database handle. So we're going to be forming up some structured query language here, and we will expect to get back a return code, and we may also have an error message. So we will create 3 variables to hold that information. So the first one we're going to populate is the SQL itself. This is a command we're going to give to SQLite to create our table if it does not currently exist. The SQL is telling SQLite to create a table if it does not exist. We're then giving the name of the table, in this case TBL staff. We're then following that with the details of what is contained within that table. We have a column called ID, which is an integer, and it's going to be our primary key. we have an additional column or field called name, which is going to be text, and a final column which is age, which in this case is going to be an integer, a number. So in order to execute this piece of SQL, we're going to need another function. So we'll go back to the beginning of our code and declare a new function. So there is our new function, SQLite 3 execute. This will allow us to execute SQL commands on our database. As you can see, it's taking 5 parameters: the database handle, the SQL we wish to execute, a callback value, an argument, and then a message if we have any errors. So here is our command calling SQLite execute. As before, we're taking a return code value. And there are the parameters we're passing: the database handle, the SQL we have just populated in the SQL variable. For the moment, we're going to have the next 2 parameters as 0, and then the final parameter, which is a pointer to the error message should one occur. We'll handle the error messages later. But as we've done before, we can test the value coming back on our return code to make sure that it equals SQLite. If the value is not SQLite, then we can say we're unable to create the table. If the value is SQLite, we'll return the value true from this function. As you will see from the SQL statement, we are only attempting to create the table if it does not currently exist. So if the table does currently exist, we will not attempt to create the table and no error will be generated. So as we can see from our database at the moment has a 0 size. If we try a test compile now, we will see the application does not compile, as we have not declared the value of the true constant. We could set these up quite easily at the beginning of the code. But just in case we're wanting to use any of the Windows API calls later, we will put an include file in. This include file will bring in the both true and false constants. So if we compile now, it will compile quite cleanly, and we can run our application. So there's our database opened. It's telling us the table has been created and the database has been closed. So if we have a look back in our code folder, we will see the testdb file has now got a size greater than 0. It's now 8K in size. So creation of our table has obviously put some information into that file. So now that we've created a table, can we put some data into it? So after the call to the create table function, we will attempt to insert some rows of data into our database. So we're going to create a new function called insert rows, taking 2 variables, the first being the database handle, and the second is going to be a variable which we want the function to populate, saying how many rows have been inserted. If this function returns true, then we will report that all rows have been inserted. Otherwise, we will say exactly how many rows it did manage to insert. So we're going to have to declare this row count variable. So there is our local variable, row count, now declared. So let's go and create this new insert rows function. So here is the skeleton of our function with its 2 parameters. We'll want to insert in this function multiple rows. So I'm going to set up a local array to hold the SQL for each of these inserts. This array has 3 elements, as I want to have 3 attempts at inserting data into this table. And I'm going to create a number of other variables, one for the return code, one for an error message should one occur, one as a statement counter, and one as a pointer for the error message. We're going to handle error messaging within this function. So first we will populate the array of SQL statements. So there are our 3 SQL statements. We want to insert into, and we're naming the table. We're then specifying the fields we wish to populate, in this case the name and the age, and the values we want to put into those fields. The first one, the name for the first SQL statement, is Tom Smith, and the age is 25. You will see that the first parameter, Tom Smith, has been bounded with single quotes, This is a standard way in SQL of determining the beginning and the end of a string of text. So now that we have those 3 SQL statements, we're going to use a very simple for next loop to step through each SQL statement in turn. So we're going for 1 to the upper bounding of the array, which is 3 in this case. A call to the SQLite 3 exec command, as we did before when we created the table. We're giving it the database handle, the SQL to run, and then a variable to hold any possible error message. And as we've done before, we're going to be testing the value of our return code. Does it equal SQLite or not? If it does equal SQLite, then we're incrementing the row counter to indicate that we have successfully inserted a row of data. If that does not return that value, then we want to handle our error. So we'll put a message out to the console to say SQL statement, and whatever number it is, cannot be run. Now we want to reveal the error message to the user, which will give them more information on what the problem with the SQL statement was. We can do this quite easily by using a pointer. We will populate the pointer variable with the value that come back from the database. And then we can print that out to our log by using the @ followed by the pointer variable. And as the final part of this function, we will return either true or false. If the row count equals the upper bounding of the array, in other words, if we've inserted 3 rows successfully to the database, we will pass back the value true. Otherwise, we will pass back the value false. So if we attempt to compile to make sure it all compiles cleanly, and we run the application now, it will tell us all rows have been inserted. So we have an indication that we have indeed successfully inserted 3 rows of data into the database. If we look at the code folder, we'll see the database file is still 8K in size, so it hasn't got any larger. So how do we know this data has actually been inserted? We'll need to write another function to read data back from the database. So we're going to create another new function called readData. We will first zero out the value in the row count variable, and we're going to be returning the number of rows we've read from the database in that value. So our new function, readData, is taking 2 parameters, the database handle and the row count, which it will populate and pass back. We will then print out to our console the number of data rows read from the database. So let's go and create that new function. So here is the skeleton of our new function taking its 2 parameters. As before, we will need some local variables. Here is the first set of variables, which will be fairly obvious considering what we're going to be doing. We need a variable for the SQL statement. We need a variable for the return code. We may have an error message, so we'll need a variable for that. And we're going to have a variable for the statement ID. And there is another variable we'll need to specify, but we're not going to be using it in this particular function. This is one called tail. We'll cover that in later videos. Finally, as we'll want to actually print some of this information out to the console to confirm it has actually arrived at the database, we're going to create variables for each of the fields. So we have one for the primary key, we have one for the name, we're going to be using a pointer for the name, which I'll come back on in a moment, and finally a variable for the age. So first we will populate this SQL statement. And this is a quite straightforward select followed by the 3 fields that we wish to pull out of the database. The ID column, which is automatically populated by the database, the name column, the age column, and then followed by the word from, which designates which table we're pulling information from, in this case, table staff. The final variable is the order we want them sorted by. In this case, I've got it set for order by ID. You could of course make it order by name or order by age. It defaults to ascending order, but you could have descending as well. So next, we'll need to use another function within our SQLite library to pull this information out. This is a prepare statement, which prepares the SQL for running in the database. So this is another new function we'll need to declare at the beginning of our code. This is the SQLite 3 prepare version 2 function. It takes 5 variables: the database handle, the SQL we wish to run, a byte variable, a statement variable, and another tail variable. This function, of course, has a return code. So does the value coming back from this function equal SQLite OK or not? We can return the value false and we'll exit the function immediately. Should we get past this section of code, then we're ready to pull the information out of the database and display it to the user. So first we're going to print out the name of the columns, because we have them up here in the select statement. ID is the first column, followed by name, followed by age. And we're going to use a do loop here, because at this point in the code we don't know how many records actually sit within the database. We know when we ran previously there are 3 records in the database, but there could be many more than 3. So we're going to use yet another function within our SQL library to pull back the first row. And we're going to run this in a loop until there are no more rows to return. So the value coming back from the return code we'll need to test. So there are 3 possible values that this could have. If it says SQLite row as the return code, then we have successfully picked up a row of data. If the value coming back is SQLite done, it means there is no more data. If it's something else, then some kind of error has occurred, and we can then print that out to our log and let the user sort it out. If the value returned is SQLite done, then we will mark the function as true and exit the loop. So now all we have to do is to put the code in to handle when we have data to display to the user. And in order to do this, we're going to have to handle 2 more functions within our SQL library. So first of all, we will declare the step command. It takes a single parameter, which is the statement number. Next, we need to handle both text and integers. So we'll need to declare those 2 functions as well. These functions are used to return both text and integers, and take 2 parameters, the statement number and the column number. So if we go back to the read data function, we'll get the primary key from our database. So we'll call one of these new functions column integer, because we know the primary key must be a number. We're telling it the statement ID, and we're looking for column 0. Column 0 is the very first column. Next, we can use the same type of call to get the name. In this case, we're populating the pointer name variable, and we're pulling back what is in fact a pointer to the name. And we can populate the name string by quite simply putting the variable equal to the @ and then the pointer handle. So strname is going to contain the name column value. And finally, we'll get the last column, which is the age. And it uses the SQLite 3 column int function. So we're getting column 0, which is the first column, column 1, which is the second column, and column 2, which is the third and final column. We can then print all the details out to our console: the ID, the name, and the age. We're using the comma between each of these variables in order to separate the columns on the console. And our final task is to increment the row counter to say we've effectively pulled back a row of data. So once we've exited the loop, there's a little bit of finishing up we have to do. There's one last function we need to call, which is SQLite 3 finalize. So we will declare that again at the beginning of our code. This function takes only 1 parameter, which is the statement handle. So we make the call to this passing its single parameter, and if the value is not SQLite OK, then we'll print out a message to say there's been some problem finalizing. So I'll quick compile to see if that compiles cleanly. As you will see, the application will attempt to create the table, which it will not create because it's already there. It will then reinsert more rows, so there should now be 6 rows in the database. And it will then attempt to read back all those rows from the database and display them on the console. So if we run the application now, we will see there are indeed 6 rows in the database. It has inserted the data twice. It was there the last time we ran the program and has now been reinserted because our SQL makes no attempt to check to see if the data already exists in the database. So how would we handle errors? Let's go back to the code and we will make a change to one of the SQL statements. And we will change the text of one of the SQL commands to take the S of values and change it to value. This should mean this SQL is not syntactically correct. If we attempt to run the code now, it will tell us that 8 data rows have been read rather than 9. So it says SQL statement 3 cannot be run. And the error message we're getting is near the word value, and it's a syntax error. And it's telling us that there were 2 new rows inserted to the database, which took it from 6 rows of data to 8. So we have successfully picked up an error in the SQL. So it's always important to test the value coming back from each of these functions to ensure that the function you're calling has successfully completed. So in conclusion, what we've achieved today is we have used the SQLite 3 DLL library. We have called a number of functions to first of all create a database if it does not currently exist. We have then used a piece of SQL to create a table if it doesn't currently exist and define each of the columns within that table. We then inserted a number of data rows into that table and successfully read them back. We have also instituted error handling, so that should a piece of SQL not be syntactically correct, then we can display an error message on screen. So this has been a very short introduction to the use of SQLite. We will cover more details of SQLite in future videos, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.